Hey everyone, welcome to Singularity Beast 2 Build Log Part 14. At this point in time, I am almost ready to fill the water cooling loop. I just need to finish the wiring and tube up. I've already started installing the fittings and most of the tubing is actually done because I have already tubed up using Bits Power Crystal Link between all 8 of the water blocks in this system. Okay, before I get started, I'm going to give you a look around the system and talk about where I'm at and some of the things that I haven't already mentioned. I'm also going to answer some of the comments and questions from the last few videos. Okay, so first of all, the SLI bridge is upside down for a reason, as I've mentioned previously. Most SLI bridges have tabs. On this SLI bridge, the tabs are actually on the opposite side to what they normally are. So it actually doesn't fit the right way up. Now, I could sand off and remove the tabs, but I'm actually planning on upgrading the graphics cards soon anyway, as I mentioned, to high-end Kepler, even when it comes out. And it will probably fit on the new graphics cards because it's only these specific graphics cards that it doesn't fit on. I have tried it on some others and it fits. So I'm just going to leave it upside down for a little bit longer instead of butchering a lovely black Republic of Gamers SLI bridge. Okay, the Noctua fans. When I chose these fans for this build, I knew I was going to get a lot of comments about the colors, and sure enough I have. Obviously I didn't choose these fans for their color. I chose them because of what I know about them. And because of what I know about these fans, the color actually doesn't bother me personally. Obviously I know it doesn't suit the build, it's never going to suit any build. But when it came to choosing the fans for this build, my own personal system, there was no question about it. I have tested and used a lot of fans in my time. I would actually say that fans are the component that I've tested the most of. I'm constantly testing different fans in my different builds, and some of you will notice that I go through a lot of different fans, and that is because I'm constantly testing them. Taking that into consideration, obviously I've chosen these fans for good reason. This system is obviously not finished. Recently I spent 4 days in a row working on this system. I had 4 days of downtime, and that is what this entire rebuild has been so far. These build log videos have been from that 4-day period, and in those 4 days I spent over 50 hours working on the system. A lot of that time was also spent on the filming, but in that time my primary objective was to rebuild the water cooling loop and complete it. But nothing else. So the wiring is unfinished, the fan configuration is unfinished. There's a lot of other things that I still need to complete in this build. Now I had no intentions of running Noctua fans like I am in full sight. I'm going to stealth the fans. They are going to be completely hidden. You are not even going to know what fans I am running in this build. So you can look forward to that coming up in the build log. Okay, now for a brief look at the Noctua NF-F12. Coming up, I'm going to do a review on this fan, and I'm also going to do a fan roundup where I test a whole bunch of different fans for air cooling and water cooling. Okay, now for a look around the packaging at some of the technology behind this fan. From this, you can see some of the effort that Noctua has put into this fan. Now, I'm not going to go too much into any of this because I'm going to speak a lot more about it coming up in the review. So I think it's safe to say that Noctua puts more R&D into their fans than anybody else, and it shows. I think they can get away with a color scheme like this, and really that's the whole point. Think of their color scheme as a logo. Noctua fans are always instantly recognizable, whereas other fans with common normal color schemes just blend in with the rest. These fans have an incredible 6-year warranty and a 150,000 hour mean time before failure. Okay, now for a look at what comes with the fan. We have some anti-vibration mounts which match the lovely color scheme of the fan, a dual PWM splitter which is sleeved, a low noise adapter which is also sleeved, and a sleeved extension cable which is 300 millimeters long. Also some mounting screws. Okay, now for a quick look at the fan itself. I'll just go over the basic specifications. The speed is 1500 RPM, airflow 93.4 meters cubed. The noise output is 22.4 decibels. The static pressure is 2.61 millimeters H2O. The power consumption is 0.6 of a watt at 12 volts. This is a 50% better power consumption than most other fans in this speed range. You can see the fan has integrated anti-vibration pads. It has 7 blades which have been optimized to work with the focus flow frame. You can see the stepped inlet design, which is actually designed to add turbulence to improve the suction of the fan and also the intake noise. At the center of the fan you can see the SSO2 bearing, which has a number of optimizations over the SSO bearing. So it increases the life of the fan, improves the efficiency, power consumption, also again the noise output and performance. You can see the focus flow frame, which has a number of different technologies included, including the vortex control notches. So it's designed to focus the airflow of the fan and also spread the noise emission over a broader, basically spread out the noise, and also to change the sound so that it is not necessarily quieter, but a type of sound that is more agreeable to the human ear. This fan has the usual Noctua sleeving, which is a densely weaved kind of rubberized material. You can also see the PWM connector. So I've only just brushed the surface here. You can look forward to a far more detailed look at this fan in my upcoming review. Okay, moving on to the drainage system that I've set up for this build. So I've used a Bitspower 5-way multi-F block, and I've connected that to the radiator using a mini D-plug. I've then used a 90-degree triple rotary fitting, and to that I have connected a Bitspower tap. I then just have a stop fitting in the end of the tap. On top of the 5-way multi-F block I just have a compression fitting, and because there's 2 openings underneath the multi-F block, I've just used another stop fitting underneath it. Then on the end I'm going to install a Bitspower plug temperature sensor. Now this allows me to drain the system from the lowest point. This is the lowest point in the build. It's the bottom 480mm radiator. And because of the way I've set this up, as you can see, I can actually rotate the fitting and angle it so that it actually goes below the 480mm radiator. So it means that I can drain almost the entire water cooling loop from the front of the build in minutes. It just makes things so much easier if you have a properly configured drainage system. To let air into the top of the loop, I'm just going to use a coolant quick disconnect around the back of the build, just underneath the 480mm radiator. Okay, now for a look at the cable management that I've done so far. Keep in mind, it's all temporary because I'm going to be replacing the power supply coming up soon. As you can see, I've done the 24-pin motherboard power. Now I've just tied it up like that temporarily. Soon, when I put all of the other cables in, I'm probably going to tie it to the other cables. So I'm just getting it to bend up like that, just to get it to the correct height so it doesn't look like the cables are sagging from around the front of the build. Down the bottom here you can see that I've started doing the cable management for all of the front panel connectors and also the 2 pumps. Okay, the way that I've configured the fans is completely temporary. I'm going to go back in and reconfigure them when I redo the wiring. All I've done so far is connected all of the fans to quad PWM splitters, which draw their power from a 4-pin Molex. But I'm only going to connect up the 4-pin Molex. So all of the fans are going to run off Molex at 100% to begin with, and then when I redo the wiring, I'm going to connect them all to the Aquaero, and I'm going to use the Aquaero to monitor and control my entire water cooling system, all the fans, the pump RPMs, the temperature of the coolant, and also I'm going to have other temperature sensors around the system. Okay, it's now time for a look at the Aquaero 5 Pro. I'm just going to give you a brief look because coming up I'm going to do a review. I'm also going to talk a lot more about it in the build log once I have it all set up and configured. I'm going to show you my entire configuration, talk more about why I chose it for this build, and also exactly what I'm going to be using it for. Now, when it comes to monitoring and control, you can't go past the Aquaero. There's actually 3 versions. This is the Aquaero 5 Pro. Below this there is the Lite, which actually doesn't have an LCD, and it is actually all about the software, and that's what I'm most excited about when it comes to the Aquaero 5 Pro, because it comes with software which allows you to access the full functionality from within your operating system. So all of the control and monitoring, you can monitor anything that you connect to it from within your operating system. Now, the Aquaero 5 Pro, as you can see, comes with an LCD, so you can access all of the functionality through the LCD as well as the software. And above this, the Aquaero 5 XT comes with the software, LCD, and also a remote control. You can see I have some other components to go with the Aquaero 5. I have a flow meter, also an inline temperature sensor, and I have the black faceplate to replace the silver one so it matches my build better. And that's one of the amazing things about the Aquaero. There are so many accessories and add-ons that you can purchase for it, and they are also constantly developing it. Now for a look around the back of the Aquaero at the connectivity. So obviously it fits into a 5.25 inch bay. Now I'm only skimming the surface here, and as I mentioned, all of this is expandable. So it has a 4-channel fan controller, it has 8 temperature sensor channels, it can be connected to your system via USB so that you have full control and access to its functionality through the software. It has RPM sensor connectors and flow sensor connectors. You can even connect RGB lighting to it and do things such as set it up to change the color of the lighting based on one of the temperature readings. Okay, now for a quick look at the flow meter and temperature sensor. You can see the construction and materials are extremely high quality. The flow meter is made out of a solid piece of acetal and has a brushed aluminium faceplate which just looks amazing. The inline temperature sensor has G1 1/4 threads on both sides, so you can use whatever fittings you want with it, and you don't actually have to use it with Aquacomputer devices. It has a 2-pin connector, so you can actually use it with anything with a temperature sensor header. Okay, moving on. I've decided to use a bits power plug temperature sensor because I actually have a spot for it, as I mentioned, on the 5-way multi F block. So there's no point in using a inline temperature sensor and having more clutter and more fittings if I already have a spot for a plug temperature sensor. Now this is compatible with the Aquaero also because it's just another 2-pin temperature sensor. I sleeve the cable just to, even though it's going to be out of sight, I just want my cable management to look as clean as possible, even from around the back of the build. So just to look at my sleeving, it's PET black sleeving and heat shrink. You can see I've gone up over the connector there. It's just a great way of making it look cleaner, and also it holds the heat shrink and sleeving in position better. So yeah, not the best job, again, just a quick job because it's going to be out of sight, but it certainly looks a lot better than just the bare wires. Okay, I'm now starting on tubing up. So I've installed all of the fittings, but as I mentioned, I'm not going to go over the fittings that I've used and the tubing routing until the system is up and running. Tubing up is actually one of the easier parts of building a water cooling system. The only real challenging part about it is getting the correct lengths. And the way I do this is actually first of all just install the tubing on one of the fittings, and then when it comes to the adjacent fitting, I just sit the tubing up next to the fitting. Now this is the important part. You have to, if there's a curve, you push the tubing into the exact curve that you want it in. And with curves, make sure that you don't have too much length, and you can easily see that because basically the tubing curves out past where it needs to and it looks terrible. So really, you get it as short as you can, no matter what, whether it's a curve or straight, always as short as you can, but not too short where it's actually going to be pulling on the components and putting pressure on them. That's all you really need to think about. So I don't mark it with anything. I just put my finger or fingernail in the exact spot that I want to cut it. So you can see I just did it just then. I just used the end of my finger as a marker. Now there's a lot of tubing cutters out there. You can see I use a big bulky pair of tubing cutters that works extremely well, even for, hard PVC tubing, but you can just use really any tubing cutter. Don't use scissors though, because it'll give you horrible cuts. Now I actually use coolant on the fittings just to make it a bit easier to push the tubing onto the fittings, and then with compression fittings I use a little bit of coolant again on the outside of the tubing before I tighten the compression fittings. So a lot of people worry that they don't have their compression fittings tight enough. That is how to get them as tight as possible by hand. You certainly don't need to use tools to do up your compression fittings. You can definitely get them tight enough by hand, and using a little bit of coolant on the outside of the tubing is going to help you with that even more. It means you don't have to, often with bits power fittings in particular, the compression fittings can end up taking the skin off your fingers. So also when you're pushing the tubing onto fittings, you can end up flexing components if you don't hold on to them properly. For example, a single graphics card, it's very easy to flex it if you're pushing the tubing onto the bottom of it or the top of it, for example. And if you flex a graphics card, it'll potentially damage the card itself and also the motherboard. You need to hold on to the components to make sure that they don't move at all. Putting a little bit of coolant on the fittings is also going to help with this, because it means you need to put less pressure on the tubing. Okay, I've completely finished the tubing and the loop is now ready to be filled. I just need to complete the wiring, which I'm actually now about halfway through. So I'm just going to give you a quick look around the tubing and also at the wiring that I've done so far. Now I'm actually going to leak test this system and run the pumps off an external power supply. And the way I do this, I've actually shown this a few times previously in my videos. I just use an old 500 watt power supply, I think it is, and I short the power supply, run the pumps off that, and basically that way I can leave all my wiring connected in my build, because the other way is to run the pumps off the power supply in your system, disconnect everything and leak test that way. But I like to use an external power supply just so that I can leave all of the wiring connected, because once I've finished the build and I like to get the system ready to boot before I fill the loop. Then all I need to do once the loop is full, leak tested and all the air is out of it, is just change the pumps over from the external power supply to the power supply in the system and boot. And that's it. The loop is up and running. Everything is just working perfectly straight away, and the loop is not going to leak at all. Now this here was the hardest tube, because it goes straight from one of the 480mm radiators at the top of the build to the other, and it's a very small gap. I think it's 2.5–3 inches, and basically there's no room to get your hands up in there to actually push the tubing onto the fittings. There's also no real way of getting the length. When you get a situation like that where you can't mark the lengths of the tubing at all, then I mean there is still a way. I could have used a texter or something, but if you do get a situation like that where it's too tight to mark anything, you kind of need to keep guessing and make the first one too long, check it, cut a bit off, check it again, and just, you know, usually it takes me, last time I did it, it took me about 3 tries to get that one. So I'm really happy with the way everything's turning out. You can see I've connected the 2 3-pin sensor cables to the motherboard. They come from the pumps. It turns out I didn't need to sleeve any of the pump wiring because it's all completely out of sight, but I'm glad I sleeved it just to clean up the cable management a little bit more, make it look better from around the back of the build. I've connected up the 4-pin and also the 8-pin ATX, and I've decided that I'm not going to connect up the extra power to the Rampage 4 Extreme. There's a 4-pin floppy power connector just here, and also a 6-pin PCI Express power connector. The 4-pin floppy power connector gives extra power to the DIMMs, but it's only really necessary if you populate all of the DIMM slots or you're doing extreme memory overclocking. The 6-pin PCIe power connector gives extra power to the PCIe slots, but it's only really necessary if you're running 4 graphics cards or doing some extreme graphics card overclocking. And as I've mentioned, I'm planning on upgrading my graphics cards soon, and the new graphics cards are only going to be even more power efficient. They're going to use less power, so it's certainly not necessary for me to connect up either of those. And the reason that I mean I would just connect them as a precaution, but the reason I'm not is because I really want the cable management in this build to be as clean as possible. And actually, once I swap the power supply to the AX1200i, I'm going to put a lot of time into the wiring and get it as clean as I possibly can. So now taking a look around the back of the build, I showed you all of the tubing around the front of the build. I will give you a far better look at everything later once the build is up and running. But you can see the big long tube that goes all the way from the lower 480mm radiator to the one at the top of the build. And you can also see some of the fittings that I've used, as well as the coolant's quick disconnect. So the coolant's quick disconnect in this position is going to allow me to dismantle the water cooling system, but more actually it's just for draining. So I put it right in behind the wiring there because when I undo it, it will allow me to remove the tubing from behind the wiring without having to kind of thread it out from behind the wiring. And then I can lift the tubing up and put the other side of a quick disconnect into the quick disconnect, the existing quick disconnect, and let air into the top of the loop to help drain the water cooling loop. It will probably actually drain without letting air into the top because the air should be able to bubble up from the bottom. It'll just be a little bit slower. But anyway, moving on to the wiring. So as I mentioned a number of times, this is all temp wiring, but I still have put a lot of time into it. I wanted it still to be quite neat because it could be a month running like this before I swap to the AX1200i, maybe even a bit longer, so I like to have clean wiring. So basically this is the wiring for everything except for the graphics cards and the hard drives. Okay, everything is now complete and the loop is ready to be filled. So that is actually the next step now. First of all, you can see the SLI bridge that I'm using. I only actually use this one temporarily because there seems to be something wrong with it. So I end up swapping back to the upside down Republic of Gamers black SLI bridge. So you can see that I've now connected up all of the power to the graphics cards, and also you might just be able to see the SATA data cables in the background. So I am really happy with the way things are turning out. I think this build is just looking incredible. I really actually didn't intend to go all out with the aesthetics like I have, but It's just the way I build my systems. Whenever I have the opportunity to go for good aesthetics, I will. And as I mentioned a number of times previously, I design my systems as I build them, particularly when I have complete freedom, like I do with this system. Okay, now for a look around the back of the build. So you can see that all of the cable management is complete, and I'm actually really happy with how clean I've managed to get it. Mainly considering that this is only temporary cable management, because there is a lot of cables in this build. If you consider that there's 3 graphics cards with 3 6-pin and 3 8-pin PCIe, there's 4 hard drives and an SSD, there is 16 fans, and also the Aquaero at the top of the build. Then there's also the wiring for the 2 pumps, and I have actually already added some wiring in there ready for the lighting, which I still need to install. Now the cable management is going to look completely different once I've installed the AX1200i and also changed the configuration of the fans and the way I have them connected to the Aquaero. I really plan on cleaning things up even more than they are now. So I'm going to do a lot of work on the cable management coming up. Now, as you might be able to see, I decided to install the SSD onto the floor of the case. I just mounted it there with Velcro, and this was so that I didn't have to use a second quad hard drive cage just for a single SSD. Okay, I better leave it there for this video because it's been quite a long video. In the next part of the build log, I will give you a better look around the cable management, and it's then time to choose a coolant color for this build and fill the loop. That sums up this video. Thanks for watching. Please subscribe, like and favorite if you want to see more.